Question 3. Part A asks us to express 2 cos theta minus sine theta in the form r cos theta plus alpha, where r and alpha are constants, r is greater than 0 and alpha is between 0 and 90 degrees. Give the exact value of r and give the value of alpha to 2 decimal places. So we need to express 2 cos theta minus sine theta in the form of r cos theta plus alpha. We are given the addition formula in the formula booklet, so we can use this to write r cos theta plus alpha as r cos theta cos alpha minus r sine theta sine alpha. Looking at the first terms on both sides, we can see that there is a cos theta in both, which means that r cos alpha must equal 2. And looking at the second terms, we can see that there is a sine theta in both. Therefore, r sine alpha must equal to 1. Squaring both of these equations, the first and the second, will give us r squared cos squared alpha equals 4 and r squared sine squared alpha equals 1. Adding both these equations together will give us r squared cos squared alpha plus r squared sine squared alpha equals 4 plus 1, which is 5. We can factorize the r squared in both terms to get r squared cos squared alpha plus sine squared alpha in the bracket equal to 5. We can now recognize that this is the identity that equals 1. Therefore, r squared equals 5, so r equals root 5. To find the value of alpha, we can divide this second equation with the first equation to get r sine alpha over r cos alpha equals 1 divided by 2. The r's can cancel out, and remember the identity sine alpha over cos alpha gives us tan alpha equals a half. To find alpha, we take the tan to the minus 1 of a half, which gives us 26.57 degrees to 2 decimal places. Finally, the answer to part A is we can write 2 cos theta minus sine theta as the square root of 5 cos theta plus 26.57 degrees. Part B says, hence solve for theta between 0 and 360 degrees this equation, giving you answers to 1 decimal place. We need to notice that this part of the equation is what we had in part A, and we simplified to get the answer we wrote in red. So this equation we can now write as 2 over root 5 cos theta plus 26.57 minus 1 equals 15. We can cross multiply with the denominator to get 2 equals 15 times all of this. I'll put it in brackets. So root 5 cos theta plus 26.57 minus 1. Multiplying out the brackets, we have 15 times the first term minus 15 times minus 1, which is minus 15. We can rearrange by adding 15 to the other side and dividing by 15 root 5 to get taking cos to the minus 1 of both sides gives us theta plus 26.57 equals, which equals 59.55. To get the second answer for cos, we always subtract the first answer away from 360 degrees, which gives us 300.45 degrees. we must remember this isn't our final answer. This is theta plus 26.57. So subtracting 26.57 from each one of these answers will give us our final answer. So theta equals 33.0 and 273.9 degrees. Part C of the question says use your solutions to part A and B to deduce the smallest positive value of theta, for which we have this equation. Give your answer to one decimal place. The key difference with this part C and part B is the sign difference here. It's a plus instead of a minus. Okay, going back to part A, if this minus here was a plus, then we would write it in the form r cos theta minus alpha. So if this was a plus, we would have a minus here. And the rest of the working out is the same. So we have the same r value and we have the same alpha value. However, we will have a minus here. In part B, solving the equation with a plus, we follow the same steps, but obviously we have a minus here instead of the plus. So for part C, we would have cos of theta minus 26.57 equals 17 over 15 root 5. Following the same steps, taking cos to the minus 1 of this side gives us theta minus 26.57 equals 59.55. Adding 26.57 to both sides gives us theta equals 86.1 degrees to one decimal place. This is the answer to part C.